Okay, this is probably our last topic this year in systems of equations, and we're going to go back to distance, rate, time, travel problems, and now we're going to factor in what happens to your rate when you're traveling with the wind or against the wind, or if you're traveling in water with a current, and you can be traveling with the current or you can be traveling against the current, and it affects how fast you move. So we'll go back to the distance, rate, time problems. And now R in our formula, that will stand for our rate in still air or in still water. No current or no wind. And then C will now represent the current or the wind, the rate at which either the current in the water or the wind in the air, the rate at which they're moving and how it affects you. So when you're traveling upstream going against the current, it slows you down. So that would be your rate minus the current. And when you're traveling downstream, you're going with the water, with the flow, the wind is behind you, pushing you, then you go faster. So it's your rate plus the current. And the first set of problems I want you to look at are the oral problems on page 440. It's a little matching set, and they give you some equations, and then they ask you to match the equation with the description that explains what's going on in the equation. So in this particular number 13, if I look at this, I would interpret this as it took me 2 hours to travel 30 kilometers going downstream or with the current with the wind. So that's the way I would interpret that. And you can look at the others in the book and match them up. Okay, the next problem set, the written exercises, you're given an equation and then you're asked to write the algebraic expression to represent that equation. And the first one, the rate of a rowboat going downstream is 15 kilometers per hour. So the rate of the rowboat going downstream with the water plus the current is 15. And let's look at number 4 together, and you can do the other two by yourself. The rowboat takes 2 hours to go 20 kilometers upstream. So if I just go into my plain old distance, rate, time formula, I'm traveling a distance of 20 kilometers. And I'm going for 2 hours. And I'm traveling upstream. So I'm going against the water. So upstream would be represented by R minus C. And the way you would see this, another way that you could see this, you would have the distance over the rate equals your time. And both expressions mean exactly the same thing. Okay, let's look at our first problem. And this is number 6. And it says Camille can swim against the current at 1.5 meters per second and with the current at 3.5 meters per second. Write an expression to express each fact. So going against the current, traveling against the current at this rate is just simply R minus C, slowing yourself down, equaling 1.5. And then traveling with the current at 3.5 miles per second or meters per second, you're going with the current, so you're going faster, it's pushing you along, and so the expression R plus C equaling 3.5 would represent that phrase. And then if you were asked to solve the system, this would be your system, but this exercise is just getting you set up so that you can get your mind wrapped around how you express going with the wind and how you express going against the wind. Okay, let's look at number 12 in the problem set. In a canoe race, a team paddles downstream 480 meters in 60 seconds. The same team makes the trip upstream in 80 seconds. So we're going to be asked to find the team's rate in still water and that's simply the R. And then we're going to be asked to find the rate of the current. And the rate of the current is your C. So to label your chart, we're going downstream, and then we're going upstream. So downstream would be associated with faster movement, and upstream would be associated with the slowed pace. And downstream, we could express that as R plus C, and then upstream would be R minus C. And they give me the times, so going downstream, I can make the downstream trip in 60 seconds, upstream trip is 80 seconds. And the distance that I travel is 480 meters. So this is actually a round trip problem, but I really don't even need to go there. I can set up an equation taking my downstream trip This is my downstream trip, and then I'll change to blue for my upstream trip. My upstream trip could be expressed by my time and my rate equaling the distance that I've traveled. So going back to the downstream, cleaning this up, it simply turns into this, dividing both sides by 60. And the upstream version cleans up to this. So now my system of equations becomes R plus C equaling 8 and R minus C equaling 6. Adding these together. Now, the R stands for the rate in still water. So the rate in still water would be 7 meters per second. And it's easy to go back. It's easy to see without much calculation that the rate of the water is 1 meter per second. But to figure it out, I could just simply go back to the rate equation right here, letting R become the number 7, and then it's easy to see that the rate of the current is 1. So I'm going to stop this video here and do the other even problems on a second video.